Good morning, good time zone, good afternoon, everybody. Welcome to Tradecraft Tuesday, first one of 2026. Super excited to kind of be kicking off the new year right with kind of a cool topic. Uh, First, I wanted to ask, hey, light up the chat. Let us all know where you're from, kind of where you're checking in from. We'd love to hear from you and kind of get that engagement rolling early. Moving right along. So today's topic is actually going to be inside the React2Shell exploits. So um, December 3rd kind of time frame. The internet was alive with yet another JavaScript vulnerability, and it kind of made for a very rough end to the 2025 year. And so we're going to kind of go over the ins and outs of that, what happened, how it happened, some of the detections, all that good stuff. Joining me today, I have Anna Pham, Craig Sweeney, and Bob Rudis. Anna, if you want to kick us off with kind of tell us a little bit about yourself, what you're doing here.
Yeah, thank you, Michael. So I'm Anna, as you already heard. I'm a senior technical response analyst here at Huntress. So mainly I do reverse engineering, threat hunting, and just, make the threat actor suffer sometimes with Michael and the rest of the team. Yeah, it's nice to meet you guys. So, Michigan's here. A few folks from Michigan.
Turkey.
Craig, if you want to tell us kind of where you're coming at us from.
Hey, I'm Craig Sweeney. I'm or one of the principal detection engineer and threat hunting analysts here at Huntress. I primarily try to create detection rules to help catch threat actors so that our tactical response team can help kick them out alongside our SOC. And I am joining from Hawaii, so very early morning for me.
And lastly, our special guest, Bob Rudis of Gray Noise fame. If you want to tell us a little bit about yourself.
Sure. It's great to be here, and I lead the security research and data science and deception and detection engineering work over at Gray Noise. So my teams are the ones that build all the tags, that do all the cool things, that work with all these cool people to try to identify what's happening in the world and keep everybody safe.
Most excellent. And I guess I can round it out with myself. I'm Michael Tigas, senior hunt response analyst, so one of Anna's coworkers. One of the kind of the boots on the ground. So we were doing a lot of the response and triaging efforts of this latest vulnerability that we're going to be breaking down. So we're super excited to come and talk about this. And without further ado, let's get into it. So we're here obviously to talk about React2Shell, right? CVE 2025-55182. I don't expect anybody to memorize that. I certainly don't. So React2Shell at its core is a CVSS, the Common Vulnerability Scoring System, score of 10. So basically the worst a vulnerability can possibly be. This is because it's simple to exploit. You don't really need to authenticate to anything, and you can do it basically remotely. Funny story, I actually started to prepare a demonstration for this particular kind of Tradecraft Tuesday, and it was actually so boring because it was so easy that all that popped up is a calculator. Um, and so if it ever, if it ever tells you just how spectacular cybersecurity can be, it's basically as easy as running a program on a computer, which should be terrifying because as we'll get into, this is one of the most prolific kind of web frameworks and technologies to date. I have some more details up there. This was originally disclosed by Lachlan Davidson, 29 November, but it really started to kind of come to fruition around the 3rd of December is when kind of activity started to slowly increase. And that weekend was kind of a bloodbath for kind of observing a lot of this compromise. Uh, the details up there, effects 19.0, I'm not going to read all of that, but the vulnerability itself is specifically in kind of that React server components RSC framework, and so it's not necessarily a React vulnerability. You're going to hear people say React2Shell, et cetera, but it's that underlying server component kind of handler aspect that has that vulnerability, specifically the flight protocol. And we'll get into what a lot of that means here in a second. So inside React, what is React, right? And we've kind of been throwing this around. React is a component web framework. It's written in JavaScript. It's maintained by Meta. the kind of the Facebook people, right? And it's absolutely ubiquitous on the internet. So about 7% of websites that use JavaScript use React, and that number might sound like kind of not a amazing number, but that's all websites, any JavaScript, et cetera, et cetera. It's fairly hard to kind of fingerprint how widely this is used, but React itself kind of powers kind of that dynamic loading feature that you'll see on things like Facebook. You're scrolling your feed and looking at cat pictures or whatever it is you do, and maybe it takes a second to buffer. Things are kind of populating on that page dynamically. That's React. There's a couple competitors and stuff, but that technology is what powers kind of our modern web interaction. Also included in this vulnerability is Next.js. So Next.js is kind of based on that React framework, and it builds upon it and kind of gives you the building blocks to glue everything together. It's maintained by Vercel. If you've never heard of them, they are kind of a web hosting, cloud hosting provider. Um, great people. Next.js is, again, another widely deployed uh, framework. And the the big thing to take away here is that um, these frameworks, this JavaScript kind of system that we have here is going to be everywhere, places you don't even realize. So, all right, under the hood, let's talk about server-side rendering. This is going to get a little technical. We're going to try to scale it back, right? So, client-side rendering happens in your browser. When you refresh the web page you're seeing me from right now, there is some client-side rendering going on. And so your browser is receiving some JavaScript, some HTML, and some CSS, and it's painting it all in a nice little picture. And on your screen, live streamed, here I am, right? This is kind of slow. Your web browser has to make a bunch of requests. It has to get all those resources. It has to glue it together. We got to go fast. So how do we solve that? We do something called server-side rendering, right? So instead of looking at kind of all those resources and requesting them all at the same time, building that web page, we can start to assemble certain components of the web page on the server. And that server will send that assembled response to your browser. And that is much faster, right? You're only making one web request, or maybe you're making a couple of them over time. And you can wait for certain components to populate. It's also generally safer, right? Uh, Having the server render certain components of the website lets you basically trust what's going on in the server, kind of. Um, this is actually where the vulnerability goes wrong, is that we trust kind of that data flow in the server. So um, on the slide, like I said, servers have more control. Server controlled operations are safer, but this is kind of, it's the thing that makes React great, but also kind of the downfall. So like Icarus, we flew far too close to the sun in the pursuit of speed. Last technical topic before we get into some of the craziness of React is the flight protocol, right? So WTF, what the flight? Flight is a React protocol. It's a language, kind of how React expresses state, user session data, etc. And the ultimately, in order to pursue this concept of fast in the broader internet, we try to make use of this asynchronous programming model, which is essentially, hey, I don't have the answer for you right now, but if you check back to me in a little bit, I will have the answer. So in JavaScript, these are venables. You don't have to memorize that. They're also kind of promises. They're not the same thing, but in a lot of public literature, they're going to be referred to as either venables or promises. Um, so to kind of wrap that up, because I think that's a convoluted way of talking about a pretty in-depth programming concept. Um, Essentially, your web browser can go, hey, I need something to be processed, and then I'm going to get the result back at some point, and I will then go ahead and render that result or populate that data. A lot of times this is called hydration. I'll use that word in a little bit. The state of all of that, like the status of kind of what asynchronous requests we've sent, what data we've gotten back, is ultimately where this vulnerability kind of lies. We Lackland Davidson, kind of the vulnerability discoverer, essentially fools the flight protocol into losing track of which request it has and has not processed, and essentially kind of uses that to ultimately weaponize this exploit chain into remote code execution. So a lot of this research I didn't do in a vacuum. The Guillermo Rauch is the CEO of Vercel and wrote this beautiful write-up. I highly recommend you guys go and read it if you're super interested in kind of the internals there. He has a point of view that not a lot of people can have being the CEO of Vercel, but he's also a very competent developer. And so if you sit down and kind of read through that, a lot of this is going to sound very familiar. And that's chiefly because he's kind of gone through and not only summarized the vulnerability, but actually broken it down to kind of the minimum reproducible error, which is something that we don't get a lot, but it actually kind of expresses a lot of the technical nuance of this vulnerability. So some of the interesting behavior that we saw come out of it, a lot of people went in and kind of defaced public websites and said, hey, this server is vulnerable and requires immediate patching, right? So this is a .edu website. It's a widely known one. I'm going to avoid kind of listing the URLs or anything, but the general response of this was wild. You had stories coming up on Twitter of people's, wallets getting drained or their web server assets getting exfiltrated, right? This is, I mean, basically anything CVE wise that ends in shell is going to be a bad time. So that might evoke ideas of log4shell, that might tool shell, very big vulnerabilities. Um, this is just another one. So React2Shell unveiled, right? Let's talk about the exploit and let's talk about the payload. So this is what React2Shell looks like. This is Guillermo Rauch's example. This is probably not what people were using kind of widely exploited. They were likely using another POC that has proliferated across GitHub. Um, Matt Matt said, "I love tweetable exploits." Yeah, this does fit in a tweet. So essentially, I'm gonna stop here. We started to annotate this, and it ended up looking a bit like Charlie Day out of It's Always Sunny in Philadelphia. I was hunting for Pepe Sylvia. There's a lot to explain here. Your eyes are probably going to glaze over through some of this explanation, but I'll do my best to kind of get us to a point where maybe it makes a little bit of sense, and so you kind of understand a little bit about what's going on. So hopefully you guys can see my mouse here. So we're going to start with this one over here. This is what the flight protocol looks like under the hood. This is how React kind of tracks that state and those model representations under the hood. The specific points here are this $@0. Remember we talked about the concept of promises and venable. This is actually what indicates that this data is venable. So we refer to these as chunks. 1 and 0 are chunks in the flight protocol. So 1 is basically saying chunk 0 is venable. It's awaitable, right? It's a promise. And that is because we see the then method implemented. So with some imaginary magic here, we're gonna go ahead and say that, all right, this is a piece of code that we're ultimately awaiting on, and we need a way to kind of track that status. Well, if we move up here to status, we see resolved model, right? So remember we referred to like the idea of models and kind of how we express state in React. Well, we've resolved this model. So we're no longer waiting for it, right? We're ready to fulfill that promise, that request. And we absolutely can do that, right? So our response is this mess. And it looks a little convoluted, but there's two key points here. First off, we see the prefix element. Now, if you're familiar with JavaScript, this should look pretty standard. It's logging a skull icon to a console, but you can insert any manner of malicious code into that, right? What I want us to pay attention to is these two slashes here. So if you see my mouse moving. So the prefix component of this is actually put in front of some other code. And so what happens is the prefix component is evaluated. If you guys have messed around with anything kind of SQL injection looking, this should be pretty similar to the idea of commenting out that following code with the two dashes. And so what that does is it evaluates console log and simply prevents it from erroring. So we get there with the form data component. This is a data model. They are data models-ish. Rachel Smith asked in chat. They behave like data models, but this is all data that we've supplied. So this isn't React's data model. We've just confused React into thinking that something exists that we're essentially saying, hey, like I am the author of this. That's actually how they fix this. We'll talk about that kind of near the end. So essentially, anytime a JavaScript vulnerability reacts some sort of or implements some access to a constructor or prototype methods, you're going to have a bad time. So essentially, all this is saying is, hey, I have this venable data that I want to kind of await and execute. Let me go ahead and resolve that model. So now you don't have to wait for it. Just go ahead and execute it. I'm going to insert it into this $B, which is kind of a how React expresses a blob, just a piece of data. And then through some JavaScript magic, we're going to go ahead and basically throw this on the front of any code and execute it, right? That's kind of an oversimplified explanation, but anything deeper is going to require like a level of JavaScript explanation that is, we'll be here for the next 2 hours. So essentially what we're doing is we're inserting code in place of this $B. We're awaiting it, and then we're telling the flight protocol, React, hey, go ahead and execute this, right? And so ultimately, that is exactly what adversaries did. They went ahead and kind of attained this remote code execution to be able to do things like list environment secrets, to be able to exfiltrate data from web servers. And I think Anna's going to talk to us a little bit more about kind of the follow-on activity that we had. If you guys have any questions about this, there's a lot of literature out there. You're free to ask questions in the chat, specifically regarding the vulnerability. But the technical nuance of it, people have celebrated this as kind of a genius exploit because it levies a bunch of little problems in React to ultimately kind of receive that or get that code execution on the web server.
Cool. Thank you, Michael. I think there was a question in the chat. Can you repeat the lessons learned from the audience?
Yeah, so I mean, I can go over some of the lessons learned for the React2Shell exploit itself. It's going to be quite similar to Log4j and ToolShell and stuff, which is don't trust user input, right? Uh, you always have a problem if you start accidentally trusting it, which is kind of what happened here. But it ultimately comes down to the same fundamental issue, which is that Vercel and Meta's fix for this was actually just to check who introduced the code, essentially, right? It's an ownership check. And it is a small oversight, but it is so critical and led to and continues to lead to, I mean, deserialization vulnerabilities are one of the most common ones to date. And they're often very severe, right? We talked about ToolShell and Log4j, very severe. The problem comes when you're dealing with kind of this data structure in a way that allows a user to introduce their own data. So the biggest lesson learned is ultimately just to kind of continually evaluate where you stand at for what data is going into your web server, what data is it handling. If you're a developer, you need to be continually examining that posture. Deserialization vulnerabilities are often very easy to rationalize with like static application security testing tools or dynamic application security testing tools. So you can introduce, bad variables and stuff, throw it in there. If you're an end user, the biggest takeaway to any of these vulnerabilities ever is good software inventory, right? Like if you want to help kind of mitigate this and learn from these mistakes, it's to continually examine what kind of dependencies and what kind of code you're using and ensure it's, validated. Look at your logs, make sure there's nothing crazy coming into that, Next.js instance, that Vercel instance. A lot of good logging caught this essentially. And so those are kind of some of our key takeaways from this vulnerability.
Thank you, Michael. To answer the questions. So Ed says it's all new to him, which like Michael explained everything so beautifully. Like even you've read the blogs hundreds of times, right? It was a great refresher. And like including me, I forget things the next day. So it was very helpful. Thank you, Michael. So if you came to this webinar to listen to me talk about like 3 malware we have discovered during the React2Shell exploitation, you might be disappointed because we were talking about PeerBlight today. And I think that's one of the most interesting backdoor that we have uncovered during the React2Shell exploitation. And we name it PeerBlight. So yeah, let's talk about the PeerBlight overall C2 capabilities first. And I think that was the highlight of the whole malware itself. The backdoor has 3 layers, right, of fallbacks because, the threat actors, they don't want to lose control of their bots. And typically, a lot of malware developers nowadays, they write malwares with a bunch of fallbacks mechanism, just in case the C2 becomes unresponsive or being blocked, right? So let's start from the layer first here, layer 1. The layer 1 is kind of boring, hard-coded IP address, over port 8443, pretty fast, direct, and very easy to block. And once you block the layer 1, right, you figure out the IP address. Here's when layer 2 kicks in, our all good domain generation algorithm. And the domain generation algorithm. So the backdoor generates 200 domain port pairs, right, based on the hard-coded date in the binary. So it's using it to produce a seed. And we'll talk about it later. So the domain generation algorithm, it uses the Mersenne twister. You've probably seen it in a lot of other malwares leveraging Mersenne twister for pseudo-random number generation, right? And pseudo doesn't mean it's truly random. It's pretty deterministic. So you give it a seed, it will produce you the exact numbers, sequence of the numbers. And so once you figure out the domain generation algorithm in PeerBlight, right, and extract the hard-coded date, you can easily generate 200 domains yourself and then put it in your block list, right? So the developer's randomness becomes your block list. So thank you for making that one easy. And when 2 of those 200 of domains stop working, right? And you're like, we got them, game over, right? It's not that. Here's when the layer 3 kicks in. And this is where it gets pretty much very interesting. So PeerBlight joins the infected machine into the BitTorrent DHT network, and DHT stands for distributed hash table. It's how BitTorrent clients, talk to each other, connects to the client without having to need a central server that is also known as tracker. And instead of asking the server like, hey, do you have this file for me? Right? Every client becomes like this giant peer-to-peer phone book, right? Where they talk to each other. So PeerBlight connects to the BitTorrent nodes through the legitimate infrastructure, such as BitTorrent router .bittorrent.com or router.utorrent.com. And if you're seeing your production server reaching out to, like Bootstrap's BitTorrent nodes, you might ask yourself a question, why, right? Like, are you like torrenting your files on the system or like Linux images or something? That's pretty suspicious there. And yeah, so then coming back to PeerBlight, it then proceeds and finds the node ID that is very uniquely named. It starts with LOL, LOL. So yeah, that's their node ID identifier. And then they pull the fresh C2 address from that. So, now you're not just fighting hard-coded domains anymore. You're not fighting randomly generated domains anymore. You're fighting a peer-to-peer network hiding inside BitTorrent. And good luck with taking that one down. So let's move to the next slide. And let's talk about how DGA works, right? More closely here. So it starts with what I mentioned before, with a hard-coded date in the binary, pretty easy. And that date goes through the SHA-256 hashing algorithm. And then it gets processed in 4 byte chunks using rotate to left and XOR operations, mixed with a constant dead beef. Yes, the infamous dead beef. It's like, makes me hungry right now, actually. It's lunchtime. And so as a result, it produces a 32-bit seed value. And that seed value then gets fed into Mersenne twister, right? So what's interesting here is that the backdoor has 3 word lists baked in. So it consists of subjects, verbs, and nouns, not counting TLDs here, right? So the first number generated by Mersenne Twister, it will be the number that decides the order, right? So whether the formula, whether you choose the subjects plus verbs plus nouns to like merge them into like the full domain, or verbs plus nouns, or subjects plus nouns, etc. So then more numbers are going to be generated from Mersenne Twister that gives you the indexes into the word list. So the backdoors goes and be like, can you give me a word under the index 117? So the backdoors be like, here's the carpenter word, right? And so on. It does that for 200 times. Combine each word from the word list, adds the TLDs, generate a port, done. So imagine every infected machine that has the same probably hard-coded date, right? It will generate the same seed, the same indexes, the same domains. It's so predictable and so easy to detect, right? So let's move on to the distributed hash table here, where it gets a bit more interesting. Okay, you can switch to the next slide, please. Thank you. So we covered the distributed hash table at the beginning, right? Let's look at how it actually works under the hood, because I find it very interesting. When I was trying to like extract the configuration and like it didn't work, and then just had to like look at the out of disassembly again to understand what the heck is going on. So when PeerBlight finds another LOL node, it doesn't just ask for C2 IP address in clear text. That would be like so freaking easy, right? There's a whole protocol going on here. First, it's going to be, wait, did you? I think you missed the previous. I just noticed that, Michael. There's like a previous slide in there. There you go. Thank you. I was like, wait, I'm talking off the wrong slide. So, okay, sorry guys, let's start it over again here. So the validation check. So the backdoor, it validates the incoming request using a specific formula where each byte is going to be 109 times the previous byte plus 83, right? If it fails the check, you're not going to receive the configuration. And if it passes the check, the peer will give you the 2 fields here, the CG and then SG. CG stands for encrypted configuration, and SG stands for the RSA signature. So both of them, that the whole blob is going to be XOR deobfuscated, simple, but it works. So after the decryption, PeerBlight verifies the RSA signature, right? And that is designed to prevent people from, injecting fake configuration to the botnet, right? Because even if you have the right node ID, even if you manage to join the DHT network, you will not be able to pollute the configuration table without the private key. So once everything is verified, it proceeds and extracts the C2 parameters such as CNC IP, that stands for C2 IP address, CNC port stands for the port, SRVK stands for the server public key, and the timestamp. The timestamps lets the newer configurations override the older ones. So the attacker can push the updates across the entire botnet, right? If an affected machine receives 2 configurations from 2 different peers, it will keep the ones that has the newest timestamp. All right, so let's now move to that slide. The next slide. Perfect. I've been yapping too much about malware. Oh my gosh, I'm like running out of breath here. So this is like the slide that I don't like to talk a lot about, the attribution, because it sucks. Attribution is really brutal, especially if you're like trying to find a malware that, very new to you, and you're scared to like name it something different and then just get your whole like, people on Twitter calling you out for like, misattributing this or like calling another name. So it's very brutal. But anyways, when I was searching for PeerBlight indicators of compromise, right, TTPs, I stumbled like 70% of the blogs out there was about Mirai botnet. I was like, it better not be Mirai botnet because I'm so done with it. Like, yeah, we've seen so much of that, and it's like we've got so far analyzing this payload, and you don't tell me it's Mirai botnet, please. And good news is it's not Mirai botnet, okay? So PeerBlight was not written from scratch. So when I was doing some research, I found a few articles written by NetLab 360, kudos to them, covering Ping botnet. And when I read through the articles, like they have a lot of overlapping similarities, like code similarities. And just to say a few words about Ping botnet, it was a botnet that was very popular in 2021. So I think it infected about 1.6 million devices, and 96% of them were based in China. It targeted mainly MIPS-based routers, and it was so aggressive that the vendors have to fight with threat actors to take control over the infected devices, right? So the vendor would try to push the patches, and the threat actor would push the firmware to block the patches, and they would try to push the patches to the upgrade channel. Then they block the port that was responsible for the upgrade channels. So it was, it was very brutal. And, Ping botnet has a few similarities with PeerBlight, right? Like the XOR decryption here. But, XOR is pretty common. Like a lot of malware developers are using it. So this alone is not a concrete evidence of, it being the same malware. But if combined with everything else, it's going to be a data point right there, right? So PeerBlight XORs each byte with its current index, location, and a constant byte. So if you remember in the previous slide, it does that to decrypt the distributed hash table configuration. So Ping botnet, it does the same, right? But just uses a different constant. And instead of using distributed hash table, Ping botnet uses peer-to-peer model, where it listens to UDP port over port 123 and sends the probe to the hard-coded IP ranges, and then tries to receive the configuration. Does it sound familiar to you? So PeerBlight uses the similar fallback mechanism, right? But it's just DHT. So when you look at the configuration structure right here on the slide, you see that they look pretty identical, right? Ping botnet has CNC IP1, CNC port 1, server key, and verify instead of the timestamp. So nearly identical schema here. And that's not just a common pattern anymore. Like that's pretty specific. So for persistence, when PeerBlight has root access, right, it drops configurations for both systemd and upstart. What are these? They're the Linux initialization systems. So the first thing that starts when your kernel boots and is responsible for restarting all of your services. So the configuration pretty much just say go and start the backdoor when the system reboots, right? And systemd is what modern Linux system nowadays uses, like Ubuntu 15 and up, CentOS 7, pretty much everything today. And Upstart is for older Linux systems. And PeerBlight doesn't care what system it's running on. It's just going to drop two configuration and see what's going to stick. So systemd service at systemd-agent.service and Upstart at systemd-agent.config. And both are going to be pointed to the same backdoor location, backdoor binary at systemd daemon. So doing further research, right, looking for this path on Google and things like that, I saw same path, same file names were also mentioned in Rotajakira, which is another backdoor that was covered by NetLab 360 in 2021. And it was managed to stay hidden for at least 3 years without any detections on VirusTotal, right? So it's using the same persistent trick, same fake systemd service, binary name system daemon, and NetLab was linking that to the Tori botnet that was specifically targeting IoT devices based on the code similarities. So what do you see here, right? You see 3 or even 4 different malware families with overlapping code patterns. It's like a milkshake of all the malware together. And this is, you start thinking, this is either a share code, the same developer, or someone who studied these samples or families very closely, right? Either way, if you have detections for example, Ping or Rotajakira, you probably already have detections for PeerBlight. So yeah, so that was me yapping about malware here. And you probably wonder now, how do we stop this from even happening, right? How do we detect the exploitation? So this is where Craig comes in here. He's our wizard of detection engineering, and he's going to share some tips on how you can detect the React2Shell exploitation.
Thanks, Anna. I'm definitely not a wizard by any means, but here at Huntress, we do try to stay proactive and try to get detections in place that catch activity before something like a 0-day exploitation happens at scale, right? Threat actors usually weaponize POCs very quickly after they're released. So this one was released end of November, and then we saw exploitation early December at scale, right? Luckily, the threat actors didn't have the most, I'll say, evasive techniques that they did. They mass sent out similar commands to Windows and Linux hosts at the same time too, right? Like they were not being very selective on how they targeted these systems, right? So yeah, luckily they did stuff like "Who am I?" I think everyone likes to make fun of "Who am I?" and how it's an easy way to catch threat actors. So luckily we saw that quite a bit, and that was, I want to say that was one of the commands that hit almost every Windows system that we saw, right? So luckily wasn't too crazy from that regard. Yeah, never ask how am I. Yeah, they never ask how am I for sure. So we saw similar activity to other orgs such as Unit 42, Amazon, Wiz, and a few others. We released a few Sigma rules that are included in our blog if anyone wants to look at those. Also, there's about 3 YAR rules in there as well for anyone who's like worried that their systems are compromised and they want to, check to see if they're clean, right? But through and through, this was not nearly as bad as some of the other exploits, such as Log4j or something that we were kind of worried about at first. Seeing CVSS 10 is pretty scary, and you are kind of worried that systems are going to be affected in mass. So luckily that didn't happen. There wasn't much lateral movement or anything, and not much persistence as well. So luckily this was able to kind of be nipped in the bud. I think it's still being used by threat actors. We've seen a few things in the news lately, but this could have been much worse. Could have been much worse. So, that's about it from me. Michael, if you want to
Yeah, I can
change
yap a little more about this.
Yeah, the YAR rules if you want to.
Yeah, the real quick, one of the more interesting things I think we weaponized kind of very rapidly for kind of understanding and triaging these systems at scale was actually like the scanning activities from certs. Being able to like look and see kind of these like math PowerShell statements that aren't really doing
Oh, yeah.
anything. But like going through and using those to identify some of these vulnerable systems is actually pivotal in kind of how we triage and look for more information coming down from these. I think in most of the systems that we saw, there was always kind of that CERT or computer emergency response team, cybersecurity emergency, depending on where you're at. That activity helped us very rapidly kind of scale this up and presented one of the best detection opportunities I think we saw.
Yeah. Very, very different than normal. So it's kind of easy to create detections from that. I think we created quite a few on the spot, and we were able to catch quite a few things. A lot of threat hunting going on early December.
I think that's it.
Yeah,
All we have for
I think that's
kind of
about
the
it that we
detection
can kind of
opportunities.
share. I would love to share more, but we kind of got to keep that close to the vest if we can. So
So I think that now is the time to involve kind of that internet broad scaling expert perspective. Bob, what do you got for us? What do you think?
Wow, that's no pressure at all. So yeah, it was a great question. So how fast did threat actors take this up? I kind of want to tell a little story about the beginning of this because everybody got wind of it. Like I I am thankful that the big players got protected because this could have been devastating if they didn't tell the big players about this. And there was a little bit of time delay because everybody was working on figuring out exploits for those things. And the first thing I just wanted to note to everybody, so our security research team has been dealing with something we've been calling slop exploits for about 8 to 9 months now, which is just abject morons who are using AI to try to craft exploits, and they're broken. They're either researchers or they're bad people or whatever, but they don't work. And we have to sift through the proof of concepts to see if they work or don't work. So kudos to my team for putting up with that garbage because they did that. But we have great research partners like y'all and a bunch of other ones. And by the time this was ready to be handled, we had a great detection rule in place. And this was before the exploitation started. We also managed to get a bunch of completely vulnerable Next.js systems running as well too with this one, complete with ability to kind of do the artifacting on the back end as well. And for folks that have listened to me on the Stormwatch podcast that we intermittently do, like Sleep and I don't have a great relationship right now. And so I was actually up watching our platform when I saw the first thing hit. And then I saw literally, I forget the name of the Japanese poster with the wave, but then like that Japanese poster wave just boom on top of it for there. And it was really exciting. I mean, I wasn't glad to be awake, but I was glad to be awake. At least I had something to do for this particular one. And so the exploitation was absolutely massive. And I don't want to like go through like boring timelines with folks because we actually have a lot of this documented on the blog. But so my fear initially, like you all said, was, is this gonna be another log for Jay? And like, please, $80, no, not like, and it isn't another log for Jay for lots and lots of reasons, which we're not going to probably cover today. But what it is this was a great collection zoo for us to be able to collect things. So we did a blog post update the other day, and as of a couple days ago, it was 8.1 million sessions. So 8.1 million. It's actually a little bit more than that because some of the sessions were HTTP2, so they snuck a couple payloads in at the same time. But it's about 8.1 million payloads slung our way. That number is up to 11.2 million as of today. I kind of checked on there. We see like 300 to 400,000 sessions coming a day from this thing. And I just to let everybody know, this is one of the big differences between this and Log4j is like we're right about to get to 10,000 total IPs overall over time slamming the internet, probably DHCP and cycling through infrastructure and hosting providers. That pales in comparison to Log4j. So everyone kind of like went fast. They all tried to take ground. They all tried to find what was out there, and they kind of just stopped. And honestly, 50% of that 400,000 sessions we see a day come from 2 IP addresses in Poland right now. So if you're in Poland, go find those two and be bad it to them because it's not great. And so the other thing I talked about the slot exploits because I wanted to mention that AI was used for some part of this and just causing havoc and confusion at the beginning. But so we all these payloads came in, and so in the blogs that we have there, it's a link to our GitHub. If you want the payloads, they're there. We actually gave away all of the threat intel for this, so you can dig into the payloads. We actually built the Payload Explorer app that explains what a lot of the payloads are and what they do and how they actually work. We collected and we stopped because we actually have real jobs than just watching React2Shell. So we stopped at about 300 unique malware samples. We did the whole collect, blow up and like see what they did in virus total. So they're cycling through the ability to change the variable of what's going on the bits for the malware, and we decided to do a couple of things. So thanks to Census, the one thing I started to notice we saw is that there's like, and like we're not going into too many details, but there's like attackers are using all the stuff that we let them use, like, and whatever we're using, they're going to use. So they're using open source frameworks for doing remote management. Well, they deployed a bunch of those onto there, and then they enlisted those into. So we were like, is this going to become a worm? It's like, nope, no worm, because there's not enough of them. Nobody cares. It's not going to be out there. And then we're like, okay, so like now that we have all these payloads, so you saw the proof of execution, like that was the simple addition, the simple math, just to see, is this thing vulnerable? My goodness, the number of calculators being used out there for this was insane. And it's like it's easy to throw those away. Everyone was doing it, both attackers and people just kind of trying to poke around the internet. But yeah, and you guys saw all this too. Like every single conceivable piece of garbage, useless botnet malware dropping on these things was being just willy-nilly thrown to it. Now, what I did appreciate was like people did try to like mix up how they got the system command executed. I was pretty cool. And the use of the OS domains, the well-known out-of-band stuff. it was not as ubiquitous as I thought it was going to be, but it was okay. That's fair. That they get little props on there. But then we're like, what are these giant payloads? So like for folks that haven't had to do this before, you try to make the stuff as unnoisy and as silent as possible and as small as possible to evade detections. Now most of these things had no detection software on them anyway. But we saw these giant payloads coming at these things, and I'm like, what are they? So we developed a couple models to do some clustering, and there's a blog post that I just enjoyed every single character I penned on that blog post because it was a bunch of idiots using AI to try to code exploits. So they're wonderful, fully commented, beautifully indented, uh, and it's like, I can't. So people are using AI, idiots. Okay, these aren't the sophisticated ones. These are just idiots, and that's why I love it because I get to be so mean to these idiot folks that are trying to do this stuff on the internet. But it's worth going through that blog post because you get to see that's definitely AI. Oh, is this AI assisted and someone actually did it? And then some folks just and there was also this other setup too that I have to tell folks because I actually saw it play out in real time as I was going from session to session to session. So there was a bunch of folks who were actually they were typing their own exploits, and they spelled wget wrong or they spelled curl wrong, and I could just hear them sling the exploit. It fails. They look at the code and they go crap, and then they try to get it right again, and they spell it wrong again, and then you can like I'm not going to use expletives because I don't do that, but like they keep doing that, and it was like, oh, I'm glad they got frustrated so bad for these things. It was really good to see them do that. So it was just a wonderful, like little contained ecosystem of seeing what like the mid to low level like attacker space is out there like, and I'm a little encouraged by it because they're noisy, they're loud, it's the same as all the other garbage on the internet. The ones using AI have no idea what they're doing, so we got time for that. And the ones that are just trying to do it themselves and learn, like they're screwing up, and there's inept as the other ones. The bad side of all this is that's what we saw because like we're not like we didn't have a huge like so we will sometimes run deception campaigns where we pretend to be companies and it looks really cool and whatever. This was, can we get a vulnerable Next.js thing before people hit this thing tonight because we knew they were going to do it. So we got the opportunistic stuff on here, but think of all the domains like so all the like if you go to the common crawl, you can identify servers running Next.js from the common crawl with actual real domains. So no real attacker, like a really good one, no nation state, no organized crime, none of those folks had to come to me, come to my fleet to hit anything. They could just go right to those servers. And so that to the thing about like we haven't heard a lot of downfall yet for this particular thing. I'm kind of waiting for this month in California. So in California, at the beginning of the month, a brand new breach law came into effect, and they got 30 days if they got hit with this to tell anybody about it. So I'm watching all the forums and boards for those things, and I think we're going to see trickle in over the course of the next few months. Legitimate organizations say, "Hey, yeah, this thing got in and it did stuff, and it is what out there." And there's going to be about 20,000 hosts that are in that permavuln category where everyone's fighting over them, like they do fight over every piece of garbage on the internet as well too. So I had a lot of fun with this one because like it wasn't doing a whole lot of damage. Oh, I guess the thing is like, and the vibe coders, bless the vibe coders because they just gave servers to these people to go hit too. Because React is the fave thing to create for every single vibe coding thing that happens out there. So vibe coding was actually a fairly big reason why there was as many vulnerable hosts on the internet as well too. So I really enjoyed this. I enjoyed writing every blog post. I really enjoy getting permission to share everything with everybody so that you all can learn from these things. So go grab the IOCs, go grab all the things, and ask questions. Like my team loves to loves to answer questions. So if you have any questions about any of the stuff, we'll be glad to answer any of those things too, and kind of show you how all that stuff works if you need to.
Yeah, thanks for that perspective. It's really cool to see kind of how like what we're seeing aligns with kind of that broader internet
Yep.
activity and where like it just kind of fits in as a piece of the puzzle. Like uh kind of some of the crux about being like an MDR, kind of this protective sphere, is that we'll often stop attacks before they ever actually evolve into any sort of like tradecraft. So we can often mitigate a lot of this before we ever actually see things like ransomware, things like people have thrown out like Sliver, various other C2s. And so kind of seeing how that all fits into the vibe coding, um, broader stuff that they're throwing at here is definitely pretty interesting. So I think unless anybody else has anything else, we're going to skip the poll because I think we're running a little low on time. I wanted to we can linger on that slide actually, so nobody's scanning random QR codes. I wanted to open it up. If anybody has any kind of parting thoughts, any last minute questions, you're free to use the Q&A feature, and we would love to kind of answer what we can there. I know that Sharon asked what kind of post exploitation actions have been most common. The truth is, a lot of this we were actually able to stop before it got very far. Um, if if you've ever looked in like kind of like web server logs or kind of any of that stuff, you're going to see that a lot of this is really easy to detect because it all hits the same as Anna kind of alluded to earlier, like Mirai and stuff like that. Those big botnets. A lot of it looked exactly the same. Uh, Matthew asks, is this a broader trend with software supply chain compromises? Yes and no, right? So React can be introduced through some of your dependencies through that kind of that like, hey, I'm running this vendor application or something, and suddenly I have a vulnerable React server, and it was, it not super critical, mission critical or anything like that, but you're running a compromised web server now, so that's not great. But I mean, as far as like software supply chain compromises go, this isn't necessarily malware in the supply chain. It's just an introduction of a vulnerable kind of dependency. Um, so
Any other questions?
awesome. So if you guys do have any questions, feel free to kind of reach out to us. And I think everybody's pretty public on Twitter and whatnot. So you could probably hunt us down, willing to kind of field anything. I think a lot of us felt pretty impassioned about the research that we put in here. I know Anna, where in the world is Huntress these days? Can we get an at rundown? Okay, cool. So yeah, you can find me on Twitter at sudo rem, sudo _rem, sudo like the Linux command and rem like rem. Bob, if you want to plug your socials quick.
Yeah. So it's Gray Noise is on all of them. You can find them. I think everyone knows what they are. I'm at Harbor Master at mastodon.social because that's the only sad place that I live these days.
Craig,
You can find me
big
on
social guy.
You can find me on LinkedIn,
Yeah.
and I'm not there very often, but I'm there. So, what is my LinkedIn? Copy that.
So yeah, I think that's going to conclude our episode of Tradecraft Tuesday. Make sure you guys join in next month. You can scan this awesome QR code and pull it up and take you right there. But that'll be February 10th, right now at 10 p.m. Eastern Time. And
I think
moving right away.
Thank you guys for joining.
we're going to go all grab strawberry milkshakes, right?
So
Or chase the
that's plan after
Sasquatch.
this. Yeah. All right. Thank you everybody for coming. We appreciate your attendance. Everybody have a wonderful day.
Thank you.
Take care,
Bye.
everybody.
Take care.